The ocean surface is constantly dancing. Ever wonder what causes the rise and fall of ocean waters? Let's dive deep into the world of tides. Tides are the periodic rise and fall of sea levels. They're primarily caused by the gravitational pull of the moon and the sun on Earth's oceans. As the moon orbits the Earth, its gravitational force pulls the water towards it, creating a bulge on the side facing the moon. This bulge is high tide. The water on the opposite side of the Earth also bulges out due to the centrifugal force caused by the Earth's rotation. This bulge is the secondary high tide. But wait, there's more. The moon's pull also weakens on the Earth's interior, creating low tides between the bulges. While the moon plays the leading role, the sun isn't just a silent observer. Its gravity, though weaker, adds its own tug-of-war to the mix. It causes another bulge on the opposite side of the Earth. The positions of the moon and the sun in relation to Earth greatly influence the magnitude and frequency of tides. During a full moon or a new moon, when the Earth, moon, and sun are aligned, we experience higher high tides and lower low tides. These are called spring tides. Conversely, when the sun and moon are at right angles to each other, we observe neap tides with lower high tides and higher low tides. Most coastal areas experience 2 high tides and 2 low tides per day, resulting in a semi-diurnal tide pattern. This is because the moon moves to a diametrically opposite position in about 12 hours and 25 minutes. It's strange that some locations experience only 1 high tide and 1 low tide per day, called a diurnal tide pattern. The reason for this lies in the Earth's rotation and the geography of the landmass. The Earth's rotation isn't perfectly aligned with the moon's orbit. The shape of the coastline, bays, and inlets play a crucial role in amplifying or dampening the tidal bulges, resulting in this seemingly counterintuitive phenomenon. The Gulf of Mexico, Mediterranean Sea, and parts of the Red Sea are classic examples of a diurnal tidal zone. Their semi-enclosed shape amplifies the single tidal bulge, masking the opposite one. Now, let's put on our tide predicting hats. To forecast tides accurately, we need to consider the positions of the moon and the sun, and the geography of the coastline. As a general rule, expect the next high tide to be about 12 hours and 25 minutes after the current high tide. You can consult tide charts for more reliable predictions. Armed with this knowledge, you can now predict tides like a seasoned expert. Whether you're a sailor or just a curious mind, understanding the science behind tides opens up a world of possibilities. Thanks for watching. Stay curious, stay informed, and stay tuned for more exciting adventures in the world of science.